Unwiring high cardinality. Does everybody know what metric cardinality is? No? Okay, cool. Perfect. Yeah. Yeah. For you, it's boring. For you, maybe something. Yes. Yeah. And then later half of the talk is for you. Yeah. Cool. How many of you know what self-driving cars are? Yeah. You know, it's so funny. Like every time you say self-driving cars, people assume they're all electric cars. Nobody assumes that a regular fuel car could be self-driving as well. Somehow nobody assumes that. So anyway, so that's a Waymo. Uh, now imagine when a Waymo runs. It's on the street. Okay, who has been inside a self-driving car? Not the Tesla. Anybody? No? Okay. Does anybody want to be inside a self-driving car? That's it. What about the rest of you, man? Like, what are you gonna do? Yeah. Okay, followers. Okay, waiting for reviews. All right. Cool. You know, how does a self-driving car run? You know, there's signal coming in. You know, there's lidars which are constantly scanning, and there's information coming in. Then there are cameras as well. You know, and there are radars as well. Would you trust a self-driving car if it did not have any of these three? Even if it doesn't work, doesn't matter, right? But they brand it and you believe it. Yeah, now I feel safe inside the car, right? Cars are getting reliable because they claim they have this. Because they have this instrumentation, you know, like constantly hammering the street with millions of radar points. We don't even know what they look like. We don't even care what they are. But they're constantly doing that. And that gives us a sense of reliability. But with software, we run blind. We don't care. I mean, yeah, we swipe a card on Datadog and say, I got some observability. I can measure certain stuff. More sensors means more metrics. More metrics means more knowledge. More knowledge means more reliability. I assume so. Let's explain what a metric looks like. You know, I'm going to go distill down to what a metric looks like. Do you guys use metrics in your software? Who doesn't use metrics? It's okay. It's the last time you will raise your hand for this. Like, does anybody not use metrics? No? Who loves traces? Swears by traces. You save 100% of them? You save 100% of your traces? Where does that money come from to save 100% of the traces? Oh, okay. Oh, so you save other people's traces. Oh, okay. Oh, you trace your own trace. Oh, okay. All right. Okay. So, anyway, so anytime you look at a graph or a chart, right, it's effectively a metric. You know, they are the fundamental backbone of everything. Let's distill it down. I want you to imagine a cube. This is the smallest datum that will exist, which holds a recording for a certain amount of time. Now, the key thing here is it's a certain amount of time. It's not at a point of time. What that means is, say you're emitting a metric and you say, I want to measure CPU usage for 30 seconds at time t1, which represents t1 minus 30 seconds. Because there is no recording at every single interval of time. Time is infinite. You cannot have that. So every smallest datum that you capture, which is for a particular timestamp for a period of a recording. So it cannot be broken down further. So assume that to be the smallest atomic unit of your recording and your reading, which cannot be dissected further. Now think about it. If I say I saved every 30 seconds, in an hour, I would have 7,200. If that is that many data points. But if I save it every hour, I'll only have one. So you can think of this as resolution of saving more or saving less data. But as you go higher in the resolution, you cannot dissect it further because you no longer can tell which point in that point of time would it be. So if I have a recording for an hour, you cannot tell whether at the minute 1 the value was this, or minute 2 the value was this, or minute 3 the value was this. So that's the smallest cube I want you to imagine. And then everything is built on top of it. So you can stack these cubes. You want more recordings, so you'll keep stacking them. Now, this got multiple dimensions here. The cube. Each one of these dimensions are the attributes for which it can be saved. Now, when I say CPU, you understand CPU usage, right? Everybody? Okay, great. So when I say CPU usage, for what? For a server located where? In a particular data center, in a particular region or an IP address, anything that can uniquely identify the recording so that I can later use it. So these are dimensions. Now, in case of a server, it will be fairly straightforward. You can use an IP address, but not all IP addresses are going to be unique. So at some point of time, you would require a subnet as well or something as well. So these additional information that you keep are called dimensions of a metric. So far, so good? Okay, the next one. Now, it's not always just about, when I say metrics, people always assume it's going to be infrastructure. Nobody has ever imagined it could be application metrics as well. So for the rest of the talk, I'm only going to imagine non-CPU stuff, non-resource stuff, non-memory. You have a raise to hand. Oh, you support this stance. All right, you are my team. All right, cool. All right, cool. We got one follower. All right, yes. Yeah. You get one t-shirt after this. Yeah. This one do you want? Okay. So I'm going to take an example of payment completion. Say, assume you're tracking payment completion. First of all, a lot of people get baffled. Oh, can I track payment completion using metrics? Sure, you can. You must. Am I disturbing anything? Oh, okay. So payment completion seconds, right? Now, say we want to record how long does a user take to complete a payment if you're a payment provider. What are the dimensions that will be unique for us? Well, one would be the mode of the payment. Let's say I pick up a credit card. Now next to it, there's a timestamp to it and there is a value next to it. Let's break this down further. Here's a metric name, which is the first part. Then are the dimensions of it. What does this duration fall in? Because the duration could be 1 second, 2 seconds, 3 seconds, 4 seconds. You cannot record every single second. So you put them in a bucket of saying I'll have 0 to 5, 5 to 10, 10 to 15, or whatever your resolution looks like. Now, the more number of buckets you create, the finer your resolution will be and observability would be, but the more data you generate. The lesser the buckets that you have, less data you generate, but you lose the resolution. That's always a thing with metrics. Whenever you use metrics, remember, they're always aggregated. The more you want to save, the more you will have to generate, and the slower your systems may be for that matter, because you've got to save that much data. Now, there's a reported at interval, and there's a value for it. The anatomy of a metric looks okay. Cool, perfect. Now, what is cardinality inside a metric? Now, let's go back to the same metric. We were tracking the bucket and the mode. One product manager stands up and says, this is not enough for me. I only want to track successful status messages. How do I care for the ones that are failing? All right, you add one more field to it. That becomes a status field to it. The same metric now being tracked also for a status. Now, that's good enough. We've tracked that. Now, another product manager comes up. The same product manager comes up a week later and says, status is not enough. Now, I want to know which gateway is causing a problem. So we add a gateway to it. If gateway is not enough, a month later, they decide, oh, it's the Android users who are actually causing a break in the SLO. I got to track a device with it as well. So they add a device to it as well. All that is sorted. We are tracking that. But the business team realizes, wait, the processor that we are using is the problem. Maybe it's the Amex problem that we have. Maybe it's the Visa that has a problem. Maybe it's the MasterCard that has a problem. So we decide to add that as well. So you see how the same metric is increasing in the number of dimensions that it can have. So now, whenever you have a payment completion metric that is coming in with all these fields next to it. For a credit card, for a PayPal, I'm not using the real names there, for a mobile device, for a processor, payment processor, for this particular status. This is what metric cardinality looks like. The same metric, but it keeps on growing in its lifetime as your needs grow. And these needs are not unreal. These needs are pretty real. As you would go, you would want to ask more and more questions. You raise your hand. Do you have a question? Is it? I'm really sorry. There's a mic coming your way. Yes. Patience.
Yeah, thank you. I was just going to ask if the more cardinality you had to it, does it affect the dimension? You start with like a cube.
Yes, this is the dimension. Yes. Remember, the part in the middle is the dimensions. The same metric for different dimensions. As you keep adding your dimensions is what is called cardinality. So yeah, the answer is, you're right. So The cardinality is the increase in the number of dimensions. So you can no longer imagine it as a cube. You'll have to imagine it like Christopher Nolan's tessellates and all those things, right?
Okay,
Which
thank
I
you.
cannot imagine. Yeah, I never got the 5D thing, man. So 4D as well. So now, how does cardinality grow? When we had only two fields, mode and bucket. Well, 20 buckets, we divide it. And let's say we have 6 modes, assuming there's credit card, there's debit card, there's bank transfer, there's direct debit, or whatever you guys use here in the UK, I don't know. And cash maybe, or other forms of payment. Yeah. So that's 120. We add a status to it. Assume 6 to 8 status codes, multiply it, because there could be that many values, 960. You add that many gateways to it, 3 gateways probably. I mean, every product would use probably 1, 2, or 3 gateways as failover, depending on cost or frugality. You see the number growing as you keep multiplying this. The same metric, by the time you're done observing, all the fields that matter to you has almost reached 100K. Wake up. So, they're kidding. So, now just look at this. The same metric, that one single metric, payment completion seconds that we are tracking. That's almost 100,000 combinations being reported every reporting interval. You would have heard this as called as active time series all over the internet. Like every time you read active time series, this is what they meant by active time series. Basically, you're reporting that many combinations of the same metric. Now remember, this was one metric of the system. What if I bring back the CPU? What if I bring back the memory now? The infrastructure metrics. That is that many number of metrics. And this was only payment completion. We haven't seen abandonment rate. We haven't seen checkout time. There are so many other kind of metrics in the system at all points of time. Keep multiplying them by 100,000. Now the situation will look real, because whenever we say billion cardinality, we'll say, we don't have billion cardinality problem. But when you actually get to it and you mean business, where you want to measure your software, this bill racks up very easily. And which is why, we all say cloud costs always go up, observability costs always go up. This is why they go up, because our needs grow up, because we want to find those finer answers. But why do we use metrics at all? We cannot use them. Right? People say, oh, I'm not going to use metrics. I'm fine with my logs and, traces, or other people's traces. So, but you have to. Imagine self-driving cars. What if they started driving without all those metrics? Would the car be safe? No, probably. I would still sit in it, by the way. I come from SF. So, yeah. So, any mode of transport will take. So, but use of metrics, right? Now, where all metrics can help you. Things where, I'm going to see, let's bucket them down. Aggregated analysis, capacity planning, service level analysis. These are names. Let me drill them down further. How do you compare? How do you find bottlenecks? How do you find bottlenecks in a system? Okay, how many of you have dealt with servers where there are at least 1,000 requests coming in every hour? Okay, thousands where number. Okay, raise your hand. 100,000 every hour. Okay, each one of you is a scale engineer. Distributed engineers. Great. Do you dissect each and every request, or do you aggregate them and see them as a whole? Right? Beyond a point, you cannot see them as individual, right? You got to aggregate them. The moment you aggregate them, average response time last week. Who's got time to dissect every single request? No, you cannot. So all of these aggregations are metrics itself. There's nothing else. You cannot look at individuality anymore. It's not like my dad used to treat 2 of our sons. Okay, you got this, you got that. There were just 2 of us. But what if there are 8 of us? We're all aggregated, right? So capacity planning, resource utilization, CPU, it's going to be a metric. How do you do max and min? Metric. Max and min is a metric. So every time you're using an operator called percentile, max, min, they're all metrics. Service level analysis. Does anybody ever has been slapped with an SLA or is about to be slapped with an SLA breach? No? Okay, cool. These are standard things of SaaS providers, right? They constantly have to measure service performance. Am I serving the right amount of, there was a Datadog outage, right? Somebody asked a question in the morning keynote just after that, Okay, so This is always a thing that has to be measured. Like one service provider to another service provider, even inside an organization as microservice. Hey, I am good. I'm serving 99%. That 99% is a measurement. It's a metric. Long-term trends. How do you measure how much are you growing? Spend, consumption, wastage. All of these are just metrics. So they're everywhere. Now, why is cardinality relevant? We get it. Metric is good. But why are those dimensions important? Go back to the self-driving car. Now imagine you're using a self-driving car. What do you expect? Would they use high-definition cameras or low-definition cameras? If there was Jaguar F-type pace coming your way and it said, oh, we use 1 megapixel cameras for our observability, would you trust them? No, right? You expect them to use 42 megapixel. I'm going to say my phone has more pixels than your car. How is that even possible? How are you running this? What is this? This is cardinality, right? This is increase. You want to see more so that you can process more. Not because you want to hoard more data, but because you want, when something goes bad, all of this observability data, why do we gather this data? Not because we want to prove something is right, but because we want to find where is something going wrong. And for that, you need to have as much granularity as possible, but only until your kidneys hurt, because these cloud providers are expensive. Now, go back to this. Imagine, running on the road, there's cardinality, right? It's constantly scanning everything around you. Constantly. There's a person, the height of the person, the pet on the way, a zebra crossing, a weather, everything. That's cardinality. Now, go back to this. All of these fields are actually important because one of these days when things do not go right, you would want to dissect it. Well, because I got to blame somebody, right? My code is right. Who do I blame? How do I find that? All debugging ends with a blame. All RCAs end with a blame. Blameless RCAs don't exist. Now, but here's what we learned, right? Dimensions only keep growing. I have never been a part of any observability team where a product manager comes and tells me, hey, I've stopped tracking status. Don't give me status anymore. Never happens. They will always have one more field to add. Now, imagine all of this instrumentation, engineers, software engineers are emitting. So if I, as an SRE, as a DevOps, as a product, as an engineering leader, when I have to go back to an engineer and I say, can you add one more field? The answer that they gave? Next sprint. Answer I want is today, but I get it a week later. How does that work? Outage is today. How can I find an answer tomorrow? So what do? We go with a pre-computed list of all possible combinations that I may ever need because I don't want to go back to that engineer and hear one next sprint, right? What does that mean? That there are always going to be fields which I don't need today, but I may need tomorrow. But just because I don't want to interrupt that engineer or the engineering bandwidth or be blamed for slowing down a product release because some engineer is going to say, well, I was working on this observability field. I don't know. This is how a sprint got late. This is why my card is not done. So it's always going to be wastage. Different metrics have different needs. What I mean by that is CPU data. We don't go back ever looking into CPU data of more than a month, but we do go back looking into the last year's performance of things. Has anybody ever built systems here where previous year's sale or a carnival or something like this comes into the picture? Like, do you ever go back to the previous year's performance and say, last Black Friday we did this? Okay, Black Friday? Where do you come from? Oh, Christmas. Yeah. Oh, everybody celebrates Christmas. I forgot. Yes. So, cool. As data grows, right? Now, because of this, what happens is there are always silos of data that created. The product team would say, oh, we are saving our metrics into Lake 1, which is high cardinality, but only small amount of time. Infrastructure team says, oh, our data is here, low cardinality, but you can actually access it for 1 year. Different kind of levers are needed. And all of these levers result in different kind of storage needs for infrastructure needs or computation needs. And they build these silos. And all cost of cardinality is exponential. Everybody, this is the talk of the town. You walk into any talk, not just me, go to anybody who's actually in the business of providing metric, they will always say high cardinality is a problem. You ask any guy who uses Prometheus or girl who uses Prometheus and they say, do you save high cardinality data? I say, no, we don't, because they don't handle it. Because cost of cardinality is that exponential. Why is it exponential? Because storage and retrieval of that much amount of cardinality consumes energy. It takes CPU, it takes resources, it takes that much amount of resources from your computation infrastructure. Maintaining high cardinality databases, they consume exponential amount of effort. Think about it. We were SREs who were hired to solve our application performance because our own MySQL was degrading. Now I got two problems because my observability database is degrading as well. How does that work? So, right? So you start with one, but you end with two problems and maybe more. And this is where Sam Altman comes into the picture. For this, a famous tweet actually. I'm sure some of you must have read it, right? Intelligence and energy has been the fundamental limiters of many things that we want because knowledge is about cardinality. Now go for Datadog cost kidneys. Do you guys work? Who wants to argue with this? Raise your hand. Nobody. Okay, good. All right. Do you work for Datadog? No. Okay, good. Great. So, I was going to upset you. Self-managed is toil. Who likes maintaining their own observability database? Raise your hand, other than job security. Nobody. Okay, good. And open source is not free. Repeat after me. Whoever tells you open source is free is actually lying. It is not free. It takes a lot of effort to just pull out that database, that open source software, and then scale it. Because now you have two problems. You don't have one. Avoiding cardinality is avoiding actionability. Because if you don't have that data, how are you going to search it? You're going to look for alternate ways. You're going to build that finest log storage system or a tracing system, and all roads lead to Kafka. Avoiding cardinality is avoiding faster reaction times. Avoiding cardinality is avoiding knowledge. And when you do that, Sam Altman gets upset. So, until energy becomes near zero to solve and all of this becomes free, how do we solve cardinality? What's the right way to tackle this problem to begin with? A quick primer on metric lifecycle. How do metrics grow? The first stage is instrumentation, is where you code, this is how my application is going to emit this metric. You may use Prometheus exporter, you may use OpenTelemetry exporter, you may use a StatsD exporter. All of this is inside your application. You know that piece of code that you wrap and say x.observe, payment completed in y time with such status. This is code that you write. It could be a drop-in replacement of a plugin. It could be an SDK that you're using. It could be a node exporter that you're running, but that is instrumentation phase. This will be ingested into a system, which will be a system which is receiving this data, where you store it and you query it. It's a pretty standard life cycle. Where do you handle cardinality? Let's take a guess on that. If I have to change my cardinality and I say 5 more fields or 3 less fields, I'll have to go back to the developer. Oh man, they do not comply. Because when they don't comply, the CTO complains that, hey, because of you, my product line is actually going slow. Because my engineers are busy working on instrumentation, they should be shipping features. It's too early and it's too involved. Constantly going back and say one more feature. If I solve it at the query layer, it's too late and too expensive. Don't listen to me, listen to Sam Altman. He says that, right? It requires a lot of energy to compute. So the only two places where this can even be remotely handled is through ingestion or through storage. Now, there are multiple ways to tackle cardinality. I'll cover all of that. But that's the best phase if it can be computed during flight, before it has been ingested into the data, or in the storage. Because I've seen I'll give you an example of accidental cardinality explosion. So we're building a system where we decided to add path to the observability as well. And I realized somebody started putting in a real timestamp into it. Or $user ID equal to XYZ, $ampersand timestamp equal to Y. Every single recording was unique. We went from 1,000 to 1,000,000,000,000 cardinality in a span of a second. Now, if this was already hitting storage, imagine then querying a database where there are 1,000,000,000,000 rows. That would require that much capacity, which is all garbage. There's nothing in there which is of any meaning to anybody. Who's going to consume all those timestamps for URLs? Nobody. It's just already down there, corrupted my entire system. Now it's slow forever. So if it had to be handled, it had to be handled at the ingestion layer or the storage layer. Now, let's take an example again on this cardinality explosion. I want to double down on this further. Say you're monitoring 20 HTTP endpoints, 5 status codes, 5 microservices, 20 VMs. Sounds legit or fabricated? You would have done more of this for sure. Translates to around 10,000 unique time series. But well, nobody runs VMs anymore. Everybody says, oh, serverless, Kubernetes. How can there be not Kubernetes in a conference like this? So we're going to replace 20 VMs with 200 pods. And now let's say we got 10 versions of the application over lifecycle as well. Everybody does A and B here, red, green, etc. All that I'm pretty much assuming. And you want to measure whether the new version of the software is inferior or better than the previous version. If you don't do that, please do. Yeah. And it eventually translates down to 1,000,000 time series. Fairly straightforward. Our cardinality has grown. Now, what are the top 5 answers that I may need? Well, standard questions, right? Give me top 5 worst performing endpoints. Looks legit. Do you guys try to find these answers? You don't? Yeah. Okay, great. Top 5 impacted virtual machines where the problem could be. Most impacted service. Well, one of the easy answers. Look, all of these are aggregates that I'm building on top of the metric data itself, right? The same telemetry data. I'm trying to find answers. And these are standard answers. I mean, I've just taken a pick from most questions that I've chased in my life. The 99th percentile of latency. I don't know why engineers like that, but they do. Yeah. Is the latest version performant than the earlier version? Standard question. Because I want to do an A and B. I want to roll out to the rest of the system, but I do not know whether this is good or not. So if I measure the latest version's percentile latency and I compare it with the previous one, I can always say, okay, good to go. Roll out to the next 95%. Pod utilization, I just had to put it there. People love pod resource utilization. I don't know for what. Yeah. So they cannot do anything with it, but they still like it. So cool. Yeah. Now, let's imagine the amount of data scanned. Say we only have 2 use cases. We'll alert on it or we will build a dashboard. Everybody loves dashboards here, right? Pretty dashboards. Cool. But nobody likes alerts. But yeah. So imagine we're building dashboards and alerts. In alerting, I'll say, previous 15 minutes of data. You guys have seen alerts like that. Past 15 minutes, if something looks off in any one of these queries, pretty fathomable. Okay, great. Now, because we had 1,000,000 cardinality, which was here, imagine the amount of samples that are scanning for every single minute when the alert rule is refreshing. 15 million data points are going to be scanned in your database. Now, there could be an alert which says, what if something breaks over a day? Now, that's 1.5 billion. I'm not making these numbers up. This is how numbers add up. Now, imagine if you have a service level objective alert which says, if something has gone bad in the past 1 month or degraded, raise an alert. 45 billion data points being scanned every single minute. That's the amount of load that we generate on any single database out there, and that's why they don't scale. So when we say, oh, my dashboards are slow, because this is the amount of grunt work we are making our databases do underneath for finding those answers. Or now, imagine I'm building a dashboard where I'm looking at an hour's worth of horizon for the same data. Hour's worth, there were 1 million data points coming in every minute. That makes it 60 million. 1 day would make it 1.5 billion. And the moment everybody has used Grafana, right? How easy is it to expand the horizon to a month? The moment you do that, that's 45 billion data points being scanned in the database. That's the amount of load that we generate for these databases to find these answers. Poor database. Think about it. What is an ideal high cardinality workflow that looks like? It's straight out of my notebook. When I want to wake up, I want to see, is there a cardinality problem? Is there any metric which is going to break my database's back? If the answer is no, go back to sleep. Don't do anything. If, okay, for a good reason, the answer is yes, I'm going to find the bad metric now. That's what we'll do. We'll say, oh, so this is one. Have you guys dealt with Prometheus here or any others? Has anybody ever attempted audaciously to run their own metric database here? Okay. Have you ever been complained to that, hey, it's getting slower? Right? You have? Okay. All the time? All right. And what's the next thing that you do? Ah, it hurts. So, so okay. So we try to dissect what is that metric which is genuinely causing this to explode. Like you guys have run MySQL, Postgres, etc. Right? Every time people would say, "Hey, my queries are getting slow." Well, you look through the query log and understand, oh, this is the table which is actually going slower. I need to create an index here, or I need to add more resources here. Quite natural. In time series world, you find what is the metric that is causing it. Now, the next question that you ask is growth legit? I mean, it could be a guy like me who was just on the receiving end because somebody decided to inject a timestamp. Now go back to the engineering leader and I say, do you really want a timestamp in your URLs? Now, if they say yes, I do want a timestamp in my URL, I said, okay, I'll scale it up. That's what you did. Or if they say, no, I don't want that, I'll give them three options. Do you want to relabel your stuff? Should I drop this URL from your metric altogether? Should I drop your metric altogether? Because I can't scale this system infinitely. Sounds like a legit negotiation here, right? Like, I mean, this doesn't sound so unreal to happen. Like, we're not going to just keep pumping in infrastructure resources. Like, yes, we are backed by wealthy companies, but I mean, that money could be used elsewhere, could be used on a Friday beer, or something else, or my next promotion. Somewhere, give that money to me. So, or we drop that metric, or we say, aggregate that metric. Like I understand that you got all these metrics, but what if you're wise about this and rather than storing every single data point, you build queries which can be used to answer top 5 or worst 5 endpoints? I mean, that makes more sense. You don't want to save everything or any one of these. These are different workflows in absence of me deciding to throw more infrastructure at it. Once I'm done, push changes, wait if the problem goes away. If it goes away, goes back to sleep. I want to go back. If it doesn't, then I'll repeat the cycle until I've narrowed this down. This is the whole life cycle of managing a high cardinality workload when you're trying to run your own database. Now, in this, we are hand waving a lot of things. How do you find that bad metric in those millions of metrics? Have you seen developers throw metrics your way? I mean, these guys have no shame. They throw metrics. And when they throw metrics, they throw in plenty. Like there'll be like millions of metrics coming away. Like sometimes I feel like, do you even need these metrics? Has anybody in this world ever done anything about Go, GC, Num routines? You guys use Golang, right? This is a metric which is coming out every single day. I have never seen any engineer use this metric. Like I asked them, what do you do of this? Nothing. It's good to see. Like, I've never seen them do anything about JMX things as well, but they're still there. But okay, I mean, they're there. I cannot fight it. So how do you find it? You have to have a system which can tell you these are the metrics where you're going to have a threat of a cardinality breach. You know what? Somebody's trying to tell you, hey, in an hour or so from now, you're going to have a real trouble. So you can choose to ignore this or you can pay attention to this. And if you don't listen, there's a cardinality breach that happens. So you want a system which can actually tell you, I'm not going to sit every moment and say, okay, refresh. Is there anything which has broken my cardinality? Or I'm not going to wait for an engineer to say, hey, your database sucks. Like, come on, man, you threw in the metric in there. So rate control, right? Or we need flow and locality control. These are real ways on how do you stay on top of all of this explosion of data that happens. What do you mean by flow and locality control? Don't listen to me. Listen to this guy, another Sam. I think Sams are to be trusted when it comes to technology. I'm thinking of changing my name. Do you guys know who Sam Lambert is? He's the CEO of Planet Scale. So the only proven massive scale database pattern is sharding. What database do you use by yourself, by the way? Yeah. When you say your place, your home or your office? Oh, okay. Oh, SQL database, right? Okay. So, and you store metrics in it? Oh, oh, Prometheus, right? So now think about it, right? These databases are so pedestrian and so native, right? So naive right now. There's no concept of such sharding. All of these are built concepts. If I was to introduce this concept of sharding to somebody who uses MySQL, somebody who uses any Apache powerhouse of Cassandra or Flink, or or pick a name, a good database, these guys are aware of all that. But for the time series world, these are very new constructs right now, and still catching up with this entire domain of, okay, I have a meaningful workload where I may have to consider sharding into the picture. Sharding could mean both compute sharding or locality of storage as well. You may decide to do computations in certain places and then store the data in one place. This could be sharded, or the data itself could be sharded. But you can almost imagine that a meaningful database which your business is going to rely on must have this construct. But none of your open source alternates actually have this right now. They just don't have this phenomenon, but it's required. So that's data sharding, that's control sharding. Or think about this another phenomenon called streaming aggregation. How many of you are aware of Apache Spark? Apache Flink? Okay. Kafka? Everybody knows Kafka. Come on. You are not raising your hand. What do you know? You know something that I don't know. so, okay. So you guys are aware of how streaming aggregations work, right? Basically, streaming aggregation is somebody is throwing you a large amount of data. I'm going to give you a car example again. Now imagine those self-driving cars. Again, one more time. All that data coming in, sensor data. What do you think they'll be doing? They first store it in a database and then they keep querying it? Or do they act in real time? Like there's somebody in the front who shows up and the car is basically saving the data to a MySQL database, and there's a select star from pedestrian traffic where if all of this, if this thing looks like a pet, etc., somebody creates a material. No way in world they're doing that. They're basically running on this stream of conscious data that is coming into the car at all points of time. Why? Because it is such an insane amount of data. Let's learn from them. Because they are making reliable stuff. We're not making reliable software, but they're making reliable cars. It's basically stream of data coming in and then processing it at that level of cardinality to extract meaningful information out of it. Not everything. Not every raw data sample is stored in that car. At the boot of it, by the way, that is where their compute engines are. They don't save it everything. They only save what is meaningful. But that's not stopping the sensors from actually pumping in the data. They're still sending all that data. They just add new layers of knowledge extraction on top of it. That's what streaming aggregation means. Or you can think of it like, let me give you another example of it. How many of you have used materialized views in SQL? Right, there you go. Think with something very simple, right? So there's a pre-built view which is constantly getting updated, but on steroids. Now, imagine if there was streaming aggregation available. What would those scans look like? They get slashed. Because now I only want those answers. Remember my alerting rules? I only want those pre-aggregated alerting rules. I do not want to scan 15 million anymore, because only one data point, and there are 10 data points by the cardinality of by endpoint. There were 10 endpoints to begin with. My sample scanned at any point of time will be 150. My database is going to fly. I don't need to spend that much energy on top of it. I can scale faster. And by solving this, it means that I can actually save that much amount of more valuable data. Now, this is a way you stay on top of this cardinality abuse that we are going through as a world right now. But all of this must be present in the database as a lever, as a capability to be done. Because in absence of this, your only answers are, hurts. Right? And that's why we actually built Levitate. Now, this is a shameful plug here. While I explained everything else on how cardinality is a problem and how it must be solved, we have already solved it. And, Sam Altman's going to be happy, because technology prediction says that cost of intelligence energy has to go down. But until that goes down, you still need a way to solve this problem. And That is why fully managed, high cardinality, open telemetry compatible, Prometheus compatible, time series data warehouse. The only question I have for you guys is, once this cardinality is not a problem, once knowledge extraction is not a problem, you guys as SREs, you guys as engineering leaders, what are you going to do with that cardinality? How do you use that to make your software more reliable? What do you want to save in it? And that's the problem that you rather solve rather than actually trying to just throw more infrastructure at it. Yeah. Thank you. That is the white paper that we have on Levitate. You can actually download that. We've explained everything on how this has been built from ground up to solve the problem of this time series storage system. Thank you.
Great talk, Piyush. You mentioned the data points saved versus data points scanned. It
Yeah.
felt magical how you went from 15 million to 150. But how do you slash down? It's in two-part question. One is to be able for you to slash down the data scanned, you need to know what you want to query.
Yes.
And so we can never have this sort of optimization when we don't know what to query.
How do you create an index in a SQL database?
Oh yeah, I know what I want to query in that case. Yeah.
See, there you go. You pretty much know at all points of time what you can possibly, what are your key indexes to query. So you create a buy on that.
Mm-hmm.
This is like creating an index, right? So streaming aggregations are basically saying that create, generate outputs. Like, okay, think about this, right? Now let's look at this. Oh, come on, I have to go all the way back, right? If I was to save this information, what are the key things here? I'm going to have one by gateway because you may want to query by gateway. I'll say create a view which is by device. Effectively, you're not reducing your number of samples saved. You're effectively creating an index on it to say that the next time I have to query it, it becomes easier for me to reduce the search space of it. This ability to just create an index is, I think I got to return this adapter now. I'm out of time. Do I have to?
Perfect.
Yeah? Okay. All right. Cool. So does that answer the question in some way?
Yeah,
So
it does.
imagine creating indexes, right? So it's an ability to create an index which is absent, but it's kind of, see, all of this makes intuitive sense, right? Like the moment I throw an SQL analogy at you, you get it there.
Right,
But
right.
this is absent in the time series world as of today. So it's like creating a new index out of it. It's as simple as an index. That's it. Sounds like a very common requirement that should have been solved, but it's not there. But well, Levitate has that. Yeah.
Got it. Thank you.
We have a race condition. I like this gentleman's shirt. Yes.
Thank you. Yeah, great chat. So in terms of what you just said, so if you are going to define these indexes or certain labels you're interested in, is the sacrifice there like the auto discovery or the dynamicness of your data in that, say you want to set up some new monitoring for a new service, you have to go to developers and say, right, you've got all this, the high cardinality data, what are we actually interested in at the moment, as opposed to just, scraping it all and then deciding that later. So you have less cardinality, but also less dynamism in your data.
It's a multifaceted question, what I'm hearing. You're basically, if I want to reiterate it so that I understand I'm getting you right. You're saying, if I have to declare these things first up, how do I accommodate for discovery and things that are going to show up later? Let's say, and the example you're citing is a new service. Am I hearing that correct?
Yeah.
Okay, perfect. Let me answer it in two parts. One is, this is not the only way you will handle it, right? Like these are one of the many ways to handle it, which I highlighted. If there could be two cases, service showing up may show up with a different metric altogether, or it may show up with the same metric, but as a different value, right? So let's say the very famous one, HTTP request duration milliseconds. Every service emits that, right? Now the label of the service may change. But because you got your indexes pre-created, you have to do nothing because it's just one of the values that shows up, right? So that tackles the auto discovery part. The second would be, I got a brand new metric coming up. I'm a service which is, let's say, login service, right? And I say invalid auth attempts, a brand new metric, has never existed in the system before. Now, this metric I see is actually going on all smooth. At one point, I realized, oh, it's causing a max cardinality problem, or what my database is provisioned for. Now fundamentally, every new storage engine can only solve it to a certain degree. If this was being recorded, let's say you had a 4-node cluster where your payment things were happening very well and you could serve 10 million cardinality very easily. Now, suddenly you decide that for the same database, I'm actually going to start saving now every session count as well. You can pretty much imagine that the infrastructure is not going to be sufficient. Yeah? You and I don't even have to double guess this. It's evident that when it's 10 million, it's going to serve, but if it's larger, it won't serve, right? At this point, we need a way to do a localized sharding. Which is what I expressed, that when I start sharding, can I say this particular metric goes into a separate lake which has more infrastructure? That's one of the solutions that I could take. Another solution I could take is, when it fails, I'm going to create a new index on top of it. The scale out strategy could depend based on how severe or how large the metric is and how much business value does it have. Because if I go to the CTO and say, I'm going to do a session count, but I need a 50-node cluster, my CTO will say, doesn't matter, man. It's okay if this is slow. But the moment I go to the CFO and I say, I need a payment checkout count, I say, oh, yeah, throw 50 more nodes. Right? So each one of them may take a different decision based on the metric. Am I able to answer your question?
Yeah, but they're both reactive in terms of resolving the cardinality, right?
All of them is going to be, it's not reactive. It's like a strategy that you follow after a certain scale is hit. Okay, imagine you're going to pick up a MySQL database today. Nobody will say that, bring me the infinite most database ever. Most of these scale outs are a very a negotiation thing. You provision up to a certain amount. Like think about your compute infrastructure as well, right? Today, when you're going to launch a login service, are you going to launch with 1 million servers or 100 servers?
Yeah. Well, I guess I'm thinking more just like accidental cardinality, because
correct.
I give my developers an autoscaling group.
Actually, there's a cool part there about Levitate. It has these. We have actually written these data structures from ground up, so we don't use any of the existing probabilistic data structure because they're very compute heavy. So we have these flips that actually move in, which go from a coarse mode to a fine mode. So you define these like max upper limits as a system architect, that I only want 20 million daily cardinality to be served or 50 million daily cardinality. So anything which is accidental, the system goes into a circuit breaker mode and pages you to say it's one of those metrics which can actually go up. What do you want to do? Do you want to throttle it? Do you want to limit it? Do you want to drop it, etc.? So at all points of time, solving the noisy neighbor problem, basically. Like one of the metrics should not bring down the rest of the metrics. So yeah, the white paper actually covers a handful of this. And I'm more than happy to chat with you in detail about how we have done this.
Yeah, definitely. Thank you.
Yeah. Or I can conduct another 1-hour talk after this about the internals.
So my question would be around, when would you move away from metrics to an event view? That is to say you have a high cardinality and someone can't let go of their timestamp or their username or the full URL, etc., and then just transferring from storage to compute as the trade-off.
Right.
What are the kind of circumstances that you would consider that a valid choice?
I'll give you 2 answers. One, when I raise Series C is when you will do it. So, kidding. So event, it's a great part. So what we encourage our users is, and a lot of our users basically send almost very similar use cases of trillion events. They're constantly trying to create watch streams across live media devices into metrics. So those are all, I don't think you switch them. In certain cases, you already know your emission is coming out as aggregated from a code view. In certain cases, it may come out as per event itself, which cannot be aggregated at a device level itself, right? So, One of the examples could be, let's say you are a media company and you have a CD and download hit. Am I on the right track that you're trying to imagine? Okay, cool. So now these hits are going to be per event, right? And you want to say, do an aggregation of live concurrent users. Is that a kind of a use case? Right. So this, you would throw all the data to the aggregator unit and expect that the aggregator unit has a rule out there. So you should actually check out our aggregation framework. What it does is, while it allows you to create those indexes, what it also allows you to do is in-flight Prometheus queries. So you can actually run an in-flight Prometheus query, which can absorb all that billion data points and then emit a single metric out of it. So you basically shifted from storage to compute automatically. So that's what this was built for exactly that use case.
Okay, thank you.
Does somebody else?
£5 for the next question. Oh, sorry, £1.
I'm a Kenyan, so you don't have money. I was going to ask, like, some of the problems you raised with cardinality problem, or even with like storage and queries. Does this matter if you're actually running your own metric system, or do you push some of that away with like systems like Datadog or equivalents? So I want to know if it's something I need to solve, like the sharding and all of that, if I'm using like a third-party provider. Yeah. And then the second question is like, is there like an open source computing tool or that will allow me track, or is this like a feature that you expect from my third-party service where the cardinality like blows up?
I had some tough time hearing you, so I'm going to narrate that again and see if I'm getting it right.
Okay, I think the first one was if you're running your own set, if you are using a third-party system,
right?
Do you have to deal with some of these problems that you stated, or
right.
is this something to be expected as a feature?
Okay, right, understood. So I'm going to take it one by one. Yes, it's a third-party feature, but it costs. Like, you can have as many EC2 servers as long as you're willing to pay. Now, when you use something like Datadog, clearly your engineering manager hasn't come after you right now to say reduce this cardinality. They will only give you so much for 10,000 cardinality. But anyway, so they have limits, right? So, and moment you cross these limits, you have to basically pay up more, and sometimes these limits are very hard limits. And these limits are very pedestrian at times, 10,000. Again, I'm not here to diss Datadog or any service provider, but in your experience, when you actually play with those systems, you will realize that you hit those limits very fast. And any meaningful operation that you have to do, you find it very limiting to be done. So you are, in your mindset, you have reduced the number of questions that you can actually ask. So you send only that kind of data. So they are very, very frugal limits. We are talking about here millions compared to thousands, right? So it's the limit will always be there. And very soon your CTO, your director of engineering, or your CFO is going to come and say, hey, can we reduce this number of data points, etc. So while it's not your problem, but cost becomes a problem at one point of time. And yes, it's a third-party system problem for sure. But even there, you will hit a limit for that. Alternate would be you will try to do this in-house, at home, all these stunts, right? And when you do that, then you will face the scale-out problems by yourself. Second question that you asked is there an open source alternate for this?
Yeah, in terms of like tracking the problem itself, like, is it like a feature to expect? So like knowing when a cardinality is going to like blow out, like knowing when
right. These features don't exist in existing databases which are out there. And I haven't seen those, so which is why we had to build all of this as a system. One of the subsequent questions that you may have is that, are we open source? No, not yet. So, yeah.
Thank you.
Say that again. It's a good question. If we have, we got like our design principles are open source. Like none of the algorithms are proprietary. I've published them in free domain. The thing here is that, it's like there is no free version of there is no open source S3 because it's not a software that I can actually provide that you can scale. It's a service that actually makes a difference to it, right? The way we run our global gateways, the way we run our infrastructure, there's a recipe behind that. And that makes it easier. So while I could open source it, but that would be just me flexing my muscle, right? Because it's not really going to provide any benefit. Like if today S3 says, or look, Spanner, Google Spanner, right? If Google Spanner becomes open source, are you going to run the same amount of infrastructure to become Google Spanner? Google Spanner is economical because they run it at scale. It's their hardware, it's their infrastructure, and a lot of people are using it as a shared service, and the cost benefit is passed to you. It's a very similar paradigm that works for us as well. You know, we are in business because we can sustain that shared infrastructure at that scale and keep scaling it. Does that kind of make sense? So hence we never felt like there's a need for it. The need for it is, though, can we try it out? And the answer to that is yes. Yeah. Try it out and blow it and break it. We appreciate that. And some of our customers, in fact, have done that. You know, they run very large simulated test cases and then they request more features as well. You know, and yeah, that works fairly okay because we want the system to get better and we don't charge them for that.